For today's lesson, we'll be exploring what is a power. In this unit, you're going to be learning about how to use powers to represent repeated multiplication, use patterns to understand a power with an exponent of 0, solve problems involving powers, perform operations with powers, and explain and apply the order of operations with exponents. And the reason this is important is because powers provide an efficient way to record our work. The properties of powers lead to even more efficient ways to perform some calculations. And powers are used in many formulas with applications in science, construction, and design. So if you're not quite sure what all of that means yet, that's okay. You're in the right spot. We're going to learn. In this video, we're going to be reviewing a few key words. We'll talk about a power, a base, exponent. We'll review square and cube numbers. And in another video, we'll review power of a power, power of a product, and power of a quotient. No need to worry about that now. So the first thing we need to know is that a power is an expression that is made up of a base and an exponent. And if you look at the diagram below, the power is what is inside of the circle, so the base and the exponent together. So it's important for us to be able to identify all three. So the base here would be the 5, exponent is 3, and the power is 5 with an exponent of 3. So just like we mentioned before, the base in our example is 5, and that's the number that's used as a multiplier for a repeated multiplication. I'll talk more about that in a second. The exponent is the raised number used in a power to show the number of repeated multiplications of the base. So in this case, the exponent is 3. Just a little quick review about perfect squares. So a perfect square is the product of a number multiplied by itself. It is the number that can be written as a power with a base and an exponent. The exponent of a squared number will always be 2. So in our little diagram here, we have our side lengths of 3. And the sides of the box are the square roots, which we'll learn more about in our next unit. And the number of squares within the box, or the area, is the actual square number. So for example, 2 squared is equal to 4. And then the square root of 4 would be equal to 2. We won't be looking at that in this unit. Let's recall what a perfect cube is. So a perfect cube is the product of a number multiplied by itself 3 times. It's a number that can be written as a power with an integer base and an exponent of 3. So for example, 8 is a perfect cube number because 2 with an exponent of 3 equals 8. 2 times 2 is 4 times 2 equals 8. So if you're trying to remember what a perfect cube looks like, it can be represented by a cube made of smaller cubes, just like a Rubik's Cube. Our Rubik's Cube, for example, the side lengths are 3. So 3 times 3 times 3, which is also equal to 3 cubed, with a standard form or value of 27. Let's learn a little more about repeated multiplication. So there are 3 different ways to represent a power that we'll be talking about. Consider the number 125. Let's look at all 3 forms. So there's the power form, there's repeated multiplication, and then there's the standard form, which is the value or answer. First skill we're going to look at is being able to write a power. So here we know that our base is going to be 3 because that's the number being multiplied by itself. And we're going to count how many times. 1, 2, 3, 4, 5, 6. So in this case, our exponent will be equal to 6. In our second example, we know the base is 7. And in this case, there's only 1, so that means it's only being multiplied by itself 1 time. So the exponent here will be 1. In this example, we're going to take our power, write it as repeated multiplication, and then we're going to find the standard form, or the value, which is just the answer. So in A, we know that the base is 3, and it's going to be multiplied by itself 5 times. 3 times 3 times 3 times 3 times 3. We could also write it using dots in between. Okay, and that's the same thing. So the dots in the X represent 3s. A third way to write it would be using brackets, which also implies multiplication. And this will give us a standard form or value of 243 when we multiply those together. Example B, we know that the base is 7, and it multiplies by itself 4 times. So we have 7 times 7 times 7 times 7, which gives us a standard form or value of 2,401. That's the end of this lesson. You're going to move on to finish your assignment and textbook practice questions.